Welcome back, folks. In today's class, we'll be talking about the chapter number 11, and in this chapter, we will be comparing the two different populations. So, a mean of the two different populations. So, if the mean of population one is given to you, and the mean of another population is given to you, and we wanted to compare whether mean of population one is bigger than mean of population two, or vice versa. That's what we're gonna do in our today's class, and we're going to be using this formula to calculate the z-score, and this formula we will be using when you are given the population variances. So similar to the chapter number 10, when we are given the sigma value, we will use the z distribution, and when we are not given the sigma value, instead we are given the s values, we will use the t distribution. Now right now we are focusing on the sigma is known. All right, so let's try and understand this chapter with the help of an example. So here is the question in front of your computer screen. So the suppose hourly pay rate for the employees at the two large charitable foundation, Hofstede and the Choice, are approximately normally distributed with the standard deviation of 1.95 at Hofstede and 1.87 at Choice. A random sample of 45 employees at Hofstede earn a mean hourly pay rate of $29.25, while another independent random sample of 37 employees at Choice earn a mean hourly rate of $28.13, and conduct a hypothesis test at 5% level of significance to figure out if there is enough evidence to conclude that there is a significant difference between the mean hourly pay rate at the Hofstede and Choice. So as I said earlier, that we wanted to compare the two means. So there is mean one for population one, and for population two, there is another mean two, and we wanted to figure out that whether they are equal or not. Another thing we can also figure out if the mean one is greater than mean two. Another thing we can figure out is mean two is mean one is less than mean two. Okay, so these are the three different ways we can figure out. So first one, again I'll rewrite it. Mean one not equal to mean two. So that's what we're going to do in our today's class. All right, so let's try and solve this question. Now, again, because we are conducting a hypothesis test, so I need to write down the hypothesis. So the null hypothesis, whenever we are solving a question like this, HO will always be equal to that mean one is equal to mean two, or I can say mean one minus mean two is equal to zero. Both way it's correct. You can write it as mean one equal to mean two, or you can write it as mean one minus mean two equal to zero, and the alternate hypothesis will depend upon what the question is saying. So it says conduct, so we have to conduct a hypothesis test at 5% level of significance to figure out if there is enough evidence to conclude a significant difference between the mean hourly pay rate at Hofstede and Choice. Okay, so it is not saying that one is greater than the other. It's only saying is there a significance difference exist between them. So I can say I'm going to use the very first one where mean one is not equal to mean two, or we can say mean one minus mean two is not equal to zero. That there does exist some sort of a difference between the two means. So that will become the alternative hypothesis. Now, if I were to draw it onto the normal distribution graph, it's going to be a two-tail. So something like this. Two-tail means alpha value, which in this case is 5%. So that alpha value will be divided above the two tails. So here alpha over 2 and here alpha over 2. Similar to the chapter number 10, and here because it is divided over the two sections, here the value will be 0.025, here the value will be 0.975, and the value correspond to that z-score value will be 1.96 negative, and z-score value will be 1.96 positive on this side. Now, to conduct the hypothesis test, the formula we will be using is this one. And to use this formula, we must be given the standard deviation of the population. Again, I repeat, standard deviation of population must be given, and given that is in this case because we are given the standard deviation of population, which is 1.95 for Hofstede and 1.87 for choice. So thus I will be able to use this formula, this one. All right, now as I said, so we assume that mean 1 is equal to mean 2. So we will always take this value equal to 0 whenever we are solving a question on the double hypothesis using the z distribution. So mean 1 minus mean 2 is equal to 0. Now, to solve this question, x1 bar, which is given to me for 45 employees at Hofstede on 29.25 and well 45, yeah, 29.25 for x1 bar, and for x2 bar it is for 37 sample, it is 28.13, and then the remaining part, this is equal to 0, and then divided by standard deviation is given to me, which for Hofstede is 1.95 square, plus the other piece of information is also given to me, that is 45 and 1, and the other side it is 1.87 square divided by 37. Now please make sure you take your time to solve this question because the calculations can be a little tricky. I'll highly encourage you to solve this part first, solve this part, then square root it. That will give you the bottom part, and then whatever you're going to get from the top part, divide by the bottom, that's going to give you the answer. So z value, once you're going to solve this, you're going to get z value as equal to let me quickly do the calculation, it is 2.65. That's what you're going to get. So if I were to break it down for you, for this portion you're going to get 0.423, the value for this, only this particular portion, standard error, standard error. All right, now we calculated the z value as 2.65. Now if the value lies in the confidence interval region, which is this one, then I will retain the null hypothesis. Null hypothesis means there is no difference. That is the null hypothesis if the value falls in this region. But if the value falls in this outside region, then there does exist significance difference, and I will accept the alternate hypothesis. Now 2.65 is on this side somewhere here. So we can say that there does exist a significant difference between the two values. So yes, they are different. The pay rate at Hofstede and Choice. That's how you're gonna compile the final statement. All right, so hopefully you were able to understand how to solve a question like this. Now let's look into another question. And this is a question I'm taking from the book, and this is the unsolved question, question number 8. Question number 8, and the page number is 461. 461. All right, now in this question you are given the hypothesis. You just need to draw the diagram and solve this question. And another thing we need to look into is the standard deviation of the population given to me or not? Yes, of course, standard deviation is given to me, which question clearly mentions. So I will draw the normal distribution graph, and now I will see the hypothesis. This is mean 1 minus mean 2 is equal to 0. Here I will write it as here it is written as, shall I say, mean 1 minus mean 2 is greater than 0. So it will be a right tail because it is greater than 0, and it is at 0.05% level of significance. So this is the tail. So the value down here for the probability be 0.975, because this portion is 2.5% of the total area. Total area is 100%. So you go back, that's going to give you 97.5% of the area from here to here. That's why I've written 0.975. All right, now let's get going with this question. So z value is equal to x1 bar minus x2 bar and minus mean 1 minus mean 2 and divided by square root of sigma 1 square upon n1 plus sigma 2 square upon n2. So we're just going to plug in the values and get the answer. For these questions, mean 1 minus mean 2 is always equal to 0 because, as I said, in the hypothesis, we assume that they both are equal. So this portion for your question will always be 0. Okay, remember this thing whenever you are solving a question on the double hypothesis. Now x1 minus x2 bar, which is 2.56, if I go back and look into the values. So 2.56 minus 2.23 and divided by sigma 1 square. So square root of the values given to me are, let me just quickly see, 1.56 and 1.37. So 1.56 square upon 15 plus 1.37 square upon 13. Once you're going to solve this, the z value will come out to be 0.59. Now let's see where this z value is. This z value will before even I look into this, this is z test I should write, and here at 0.975 I need to figure out z value. That is 1.96 positive. So this value will lie somewhere here in the confidence interval. So for this one, I will say that we don't have sufficient evidence to conclude that there does exist enough difference between mean 1 and mean 2. So I can also say that there does not exist any difference between the two means at 5% at 2.5% level of confidence. I shouldn't use the word level of confidence. I should say at 2.5% level of significance. Yeah. So we cannot reject the null hypothesis. Can't reject null hypothesis. All right, so hopefully you were able to understand how to solve these questions. And that's about it for chapter number 11. It's a short video. I'll see you in another video on chapter number 12. Till then, goodbye.